Okay, let's finish on the back page. Finish up on the back page of this is test review number 2 for trig unit. Number 5, person X and person Y are walking on straight streets that meet at right angles. Y travels south and approaches the intersection at 2 meters per second. Person X travels east and moves away from the intersection at 1 meters per second. So for part A, find the rate at which the distance between X and Y is changing when Y is 10 meters from the intersection and X is 20 meters from the intersection. Right, we know Y is moving south. Okay. We know X is moving away from the intersection. So here's my triangle. So from the information that we can gather from what they're telling us, X is 20 meters, Y is 10 meters, and Z, the distance for the hypotenuse, we can just use Pythagorean theorem, right? X squared plus Y squared equals Z squared. Solve for Z. Z is 10 root 5. dx dt is 1 meters per second, right? The rate of change for X. Notice that person X is walking away from the intersection, so we know that over time the length for X will be increasing, so we want to leave that as a positive, 1 meters per second. Okay. Y value, however, this person Y is moving towards the intersection, so over time this vertical distance will be decreasing, so therefore our dy dt is negative 2 meters per second. Okay. Always have to consider whether your value is getting smaller or getting larger. Okay. If it's larger, then you want a positive rate of change. If it's getting smaller, then you want a negative rate of change. Okay. We don't know dz dt, so we'll leave that blank. Okay. And we're trying to find the rate at which distance between X and Y is changing. So the equation that's going to relate all these variables together is simply going to be Pythagorean theorem. X squared plus Y squared equals Z squared. We go through Pythagorean theorem. We go through a derivative power rule for each term. So 2x dx dt plus 2y dy dt equals 2z dz dt. We have everything, all the variables accounted for. So we plug all that in, and we just solve for dz dt. Right, we're going to end up having 0 equals 20 root 5 dz dt, divide both sides by 20 root 5. So our rate of change for z is just going to be 0 meters per second. Okay, for part B, at what rate is the angle theta changing at the same moment? So we're trying to find the angle, the rate of change for theta. So I'm just going to choose to involve x and y. So theta, x, and y, I'm going to use tangent of theta. Now, if you want to use sine or cosine and involve z, that's fine as well. I'm just going to choose to use tangent here. So here is my equation that's going to relate theta, y, and x using tangent. So we go through our derivative process. Tangent becomes secant squared theta d theta dt. Y over x, we have two variables. We've got to go through quotient rule. Now, notice that we do have values for x and y, but again, just like with all other related race problems, we don't want to plug in the variables too soon. Otherwise, we lose the ability to arrive at the differential variables. So we don't want to plug the x and y in until after we find the derivative. So we go through a quotient rule. F prime g minus f g prime all over g squared. Okay. To solve for d theta dt, we can divide both sides by secant squared theta. We know that secant theta is simply going to be hypotenuse over adjacent. So it'll be 10 root 5, which is the z value, divided by the x value, which is 20. Okay. And then we plug everything else in. Square both of these, cancel out, and we're left with negative 50 over 10 root 5 squared, which is negative 50 over 500, which will simply be negative 1/10 radians per second. Okay, number 6, sketch the graph of our function x minus sine of x on the interval from 0 to 4 pi. Find all ordered pairs of absolution and relative extrema and POI. Okay, we find our derivative first. X minus sine x becomes 1 minus cosine x. Set that equal to 0. So we want to find out when is cosine equal to 1, and that will be at 0, 2 pi, and 4 pi. Okay. The only critical point that's going to stand out here is going to be 2 pi because 0 and 4 pi are the endpoints. So if I plug pi into the derivative, 1 minus cosine of pi will be -1, so 2 negatives makes a positive, so that's increasing. If I plug in 3 pi, same thing, cosine 3 pi will be -1, 1 minus -1 is positive, so increasing there as well. Okay, we move on to our second derivative. F double prime, 1 goes to 0, negative cosine turns to positive sine. Set our second derivative equal to 0. When is sine equal to 0? At 0, pi, 2 pi, 3 pi, and 4 pi. Okay, we plug all that, put all that on the sine line. Okay. Sine of pi over 2 is positive. Sine of 3 pi over 2 is negative. Sine of 5 pi over 2 is positive. And then sine of 7 pi over 2 will be negative. Okay. So then we have 3 points of inflections. Relative extrema, there's no minimum, right? There's no change in sign. Same thing, no maximum. Okay. If I want to find the point of inflection, I plug all these critical points into the original function. Okay. There's a change in concavity, so we know all 3 will be point of inflection. So plug pi into the original function, 2 pi, 3 pi, and we're going to get pi, 2 pi, and 3 pi. So we have those 3 ordered pairs, and all those 3 ordered pairs are points of inflection because that's our prime changes signs. Concavity intervals, concave up from 0 to pi and from 2 pi to 3 pi. Concave down from pi 2 pi and then from 3 pi to 4 pi because that's our prime is negative. Okay. Sketch our graph, but I'm first going to put our slope and concavity on the same sign line, and then I'm going to match it up. Also, I'm going to find the ordered pairs for the endpoints. So if I plug 0 into the original function, I'll get 0. If I plug 4 pi into the original function, I'll get 4 pi. So here are all the points that I can plot: 0, pi, and pi, 2 pi, 2 pi, 3 pi, 3 pi, 4 pi, 4 pi. So increasing, concave up, increasing, concave down, increasing, concave up, increasing, concave down. Okay. Absolute extrema, we know absolute minimum will occur at 0, 0, and based on this graph, we know absolute max will be at 4 pi, 4 pi.